Alright guys, and so this lesson is on how do you know if a double replacement reaction occurs. And so double replacement reactions need a driving force, and that driving force is the formation of a precipitate. So we've seen some precipitation reactions in class. I've shown some to you and we've talked about what they are. And so the driving force behind a double replacement reaction is that precipitate formation. And so for a double replacement reaction to occur, you must form a precipitate. And so let's just clarify what a precipitate is, and so that we make sure that we know what a precipitate is. A precipitate is an insoluble product. It's insoluble. That is what a precipitate is, an insoluble product. And so we need to look for an insoluble product. Well, how do we know if it's soluble or insoluble? Well, good news for us is that there are tables that tell us so. And so you have in your packet a solubility table. So let me tell you how this table works. It works by looking at the negative ion, which is usually going to be the first column in most tables. So if you notice this column here, these are all negative ions. So they are the quote-unquote non-metal ions because the non-metals are written second. And then over here are some exceptions to the rule. So in general, you've got the rules. So like right here, everything up here is soluble. Everything here is soluble unless it's something over here. So for example, compounds that have bromine in them, or the bromide ion, are soluble unless it's like silver bromide. A silver bromide would be an exception to the solubility. It would be insoluble. But if you had sodium bromide, okay, sodium bromide is soluble because it's not sodium, is not one of the three exceptions over here. And so that's how the table works. And so let's do an example. Let's say that I gave you sodium carbonate, NaCO3. Can you tell me if sodium carbonate is soluble or insoluble? So what you do to determine if it's soluble or insoluble is you try and find the negative anion first, the carbonate. And so go over to your list and look for carbonate. And so we start to go down our list and we're looking for carbonate, and here it is right there. There's carbonate. Now, carbonate by rule is insoluble unless it's combined with ammonium or an alkali metal. Well, what's an alkali metal? Remember we talked about that in our periodic table chapter. Alkali metals are the metals in the very first column of the periodic table, the very first family, group 1. Those are alkali metals. Well, sodium happens to be an alkali metal. And so instead of being insoluble, sodium carbonate would be an exception, and this would be soluble. Let's do another example. Let's say that we had potassium nitrate. Potassium nitrate. So you need to go and look for the negative nitrate in our list. You're always looking for the second one first, because that's what our basic compounds are going to be organized by, is by the anion. So go and look for nitrate. There it is right there. There's nitrate. So the rule for nitrate is that nitrates are soluble. Are there any exceptions? There are no exceptions. So every nitrate, whether it's potassium, lithium, sodium, lead, copper, doesn't matter what the nitrate is, this is going to be soluble. Okay? And so that is potassium nitrate. So that's how you use the little table here. You look up the second one, and then you see if there are any exceptions to the rule. All right? Okay, so let's look at this reaction. Let's determine if this reaction occurs. Remember, for it to occur, one of the reactants over here must be insoluble. So with double replacement reactions, oftentimes the easiest way to do it is just to do the reaction and then look for an insoluble product, especially when you're a beginner. And so let's complete this reaction. So the ammonium and the silver will switch places, and so we get ammonium nitrate and we're going to get with that a silver chloride. Alright, so now we need to go look at ammonium nitrate and silver chloride and see if they are soluble or not. And so looking at our table, if you look at the nitrate, which is right underneath the plus sign, nitrates are, by rule, soluble. And so our ammonium nitrate is soluble, which means it's aqueous, because if it's soluble, it's going to dissolve, correct? So you would put the little aqueous sign behind it. Now let's look at our silver chloride. So looking at silver chloride, you can go down here and you can see chlorides, by rule, are also soluble, but there are some exceptions here. And one of the exceptions is silver. And so silver chloride would not obey the rule of soluble, but it would be insoluble. And so silver being insoluble means it's going to form a precipitate. So you would draw your down arrow here, or you could put an S, but a down arrow would indicate that it's a precipitate. And the formation of that precipitate is what drives the reaction to occur, because it's a favorable energy state, and that's what drives the reaction. So this reaction would occur because we form a precipitate. So let's look at a second reaction. So we have here sodium cyanide plus aluminum chloride. One thing about double replacement reactions is that both of your reactants are going to be aqueous. This will always be aqueous, this will always be aqueous in a double replacement reaction. Otherwise, you can't get the chemicals together. And so let's finish it out and let's see what happens. So have the sodium change places with the aluminum, and we would get potentially sodium chloride, and we would get aluminum cyanide, which would be AlCN3. So let's see if one of these is soluble, or if they are soluble or insoluble. Okay, well, you should know the answer for sodium chloride, but let's go look it up anyway. And so if you look up the chlorine right here is in the soluble rule, and the exceptions are silver, lead, and mercury, and sodium's obviously not one of those, and so sodium chloride is going to be aqueous. That will not cause the reaction to occur. So let's look up aluminum cyanide. And so if we look up cyanide, here's your cyanide right here, which is in the soluble rule, and there are no exceptions for cyanide, so this will also be aqueous. And so since both products are aqueous, they're both aqueous, there's no insoluble product, there's no precipitate. And remember, a precipitate is the driving force in these reactions. If there's no precipitate, there's no reaction, and so nothing happens here. No reaction occurs. These chemicals just sit in the beaker in the aqueous state, and they don't do anything. And so again, so I just showed you two examples, but they all work the same way. Look for a product that is insoluble. If one of the products is insoluble, then you would write an arrow after it and the reaction would proceed. That's the key for the double replacement reaction. So the only two reactions I'm going to ask you to predict whether or not they will happen or not is single and double. The combustion, the synthesis, the decomposition reactions, you can pretty much get any of those to occur as long as you provide the right environment, which is usually going to be enough heat. You'll get those things to occur. But the single and doubles, like in this case right here with the sodium chloride and the aluminum cyanide, they're not going to react. You could add as much heat as you wanted to it. They're not going to react together. And so these are more dependent on some other things, chemical concepts that cause them to react or not to react. And so these are the easy ways to figure them out. Okay, that's it for today.